I hope you guys are well. Um, okay, I guess we're going to try to do a little bit of this, a little bit of chores here. So let's go to our browser and let's see what's going on here for you guys, okay? Um, all right, I sent some communication to you guys yesterday. I'm going to be in our browser here. And what that communication was, let's go to our class 227. Okay, we're starting to gear up for the first exam, right? So if I go here to our page here, our class page, I sent some communication. I sent some information about test taking. So remember, we're going to have a practice test for you guys on Friday. I'll put that up. Following Monday, you're going to have your in-class exam. Okay, and it's going to be during regular class time, if possible, right, for us. Regular class time. And you're going to need the following. So here, I put up some test taking procedures for you guys. So let's put that up. So if you guys also want to do the following, make sure you even download Canvas on your phone as a phone app, because then that you get actually these messages, I guess, instantaneously as I send them. I mean, you should be getting them anyway. But here's our test taking procedures. So remember, how we discussed this in the past is we're going to need to, hopefully, first of all, you have a computer, a laptop with internet access and a camera. Hopefully that's the case, right? May not be the case though, but that's fine. Don't worry. But those that do, you want to make sure you download Chrome and you install Proctorio, the extension, and both can be found here. So I'm going to put this up and say, here we go. So you guys can get some information here about what you need to do and what you need to install. Okay, you got Google Chrome, the Proctorio extension, and how you take your exam. There's information for you guys. So I sent that to you already last night or yesterday. Hopefully you guys got that information. If you're on Canvas, you do. Also, let's go back and let's take a look here, okay? Let's see what we have. If we go back, I'm also putting here of what you need to do while you take your exam with your webcam, computer, Proctorio, right? All these things. You want to set up your computer and camera in a way that we can see your face and your hands, because we have to identify you. Some instructors are having people show an ID, student ID. Okay, so they're doing that as well. So make sure you guys are aware of how we're going to try to do some examination here. And yeah, make sure Canvas is installed on your phone app as well. And then here's something that's important for us that we're going to need to know. How do I submit my exam when I'm done? Well, what you're going to need to do is you're going to need to scan your test, your work, scan your answers, like you'll see, when I give you the test. You're going to have to scan this and you're going to turn it in as you would normally turn it in, although this is PDF, right? So if you download a free Cam Scanner app, here's a free Cam Scanner. This is going to be helpful for you guys. And I even have some instructions here about what to do with the app, right? Follow these instructions. How do you upload your PDF files using Cam Scanner? Well, first of all, you have to download Cam Scanner. Click batch for multiple pages. So you're going to click that batch, and you're going to click on the document, and you click on that PDF preview, and this is going to be how we start to, let's go up here, how we start to submit things. You're going to also need to submit your homework, and I'm going to set up, like I sent you guys already, the assignment. I'm going to edit that, but I'm also going to, as I edit, remind you guys that you're going to also turn your homework in the assignment portion, because the assignment allows you to send a PDF file. So, we're gearing up to how to submit things as well as take our final. So today, tomorrow, I'll discuss it. And of course, you'll get communication from me in more detail about how we're doing things. And we're kind of getting to where we need to go. So I just want to give you guys that kind of an announcement so you guys are aware. And you might say, what if I want to read about this stuff again? Well, it's right here. Test taking procedure. We're also going to have you guys sign this statement here when I give you a test, the academic integrity statement, right? It's simply the school's policy so that you know about it. I mean, you had it on your syllabus, so you know about it, but we're going to have you sign and date it as well. And that's going to be what we use when you submit your test as well. So this is going to be a part of your test, is this document. So I would just want to say to you, you might want to review these things as you'll be seeing them and using them. And I'll talk a little bit tomorrow, and I'll communicate via Canvas or email, right? Which is going to be the same thing. But you can also see me during office hours. So come in office hours, and if you have any additional questions. And again, if you don't have a computer with a laptop and and a camera, let me know and talk to me during office hours. All right. So let me know about that too. We want to accommodate you as well. So everybody here is accommodated. Everybody here is welcome. All right. Whew. All those announcements. Okay, good. And let's say again, I'm going to say this to everybody here. Good morning to you guys. I hope you're well. Yeah, let's see. We got a question. Yvette, will be those who do not have. Come talk to me during office hours. Get online. And that's where you need to go. Okay? So this is a question for Yvette. We already answered. Okay? And then we have a question here. Sandra, what website will be logging into to take the exam? You're going to be going into your Canvas. Okay? You're going into Canvas. And your test is really going to be under the quiz portion, so you know, Sandra and everybody. So under the quiz portion will be your test, but you're going to actually have to submit it, and I'm going to put another sort of area under assignment where you actually submit your completed exam that's in PDF, because I believe in quiz you can't submit a PDF. So I have to put how you submit that in the assignment portion, but your testing will be done in Canvas. So if you want to see me during office hours, that would be good, because you get used to doing the Canvas route. And so be familiar with that, okay? And again, if there's any other questions, you got the office hours that are also in Canvas. And by the way, if you don't get a hold of me in office hours, you say, hey, I went in and I don't see you. Email me right away and I'll accommodate you, okay? Because I get the emails automatically, hopefully, okay? So if there's any issues for office hours, then just email me and I'll log you in. Okay, these are some good questions. Anyway, I've taken care of what we call the administrative portion. All right. And there you guys go. Okay. So I hope you guys have enjoyed. Let's do the following here. Let's regroup. All right. We're going to, where are we going to? We got browser. Let's go to our iPad. Okay. And let's do this. On my website, I also have, if we go there, so you're aware, the next section, we're going to go straight here to probability distributions. I was thinking of doing Bayes' theorem, but I'm not going to do it this time. So we're going to go here to probability distribution. Okay? So this here is where we're going to be, what we're going to work on. And this is also known as probability formulas. So I want to remember or remind you guys here of a couple of things here, right? I want you to kind of read this really quickly as I go and I start to talk about probability distributions. And I'm going to look for a file. Hopefully I have it in Excel. So nevertheless, it's okay. That's fine. Let me see if I could copy some of these things. All right, well, that's fine. I'm going to have to do it a little differently. Okay, so maybe you guys can see this here. Let's go through this. All right. Okay. So I want you guys to go back and recall when we actually worked with our frequency tables and relative frequency tables. Remember, what you're seeing on top there, I asked you guys this question. I said, okay, how many children do you have? And what you guys did was you actually said, okay, I have 0 children, no children. I have 1, I have 2. We gathered this data. So this particular frequency table that you guys see here for number of children, that's what I want you guys to focus on. So when you have children, we gathered this data and we created a frequency column. We created a relative frequency column. And so what you guys didn't really know at that time is you were really working with what's called a probability distribution here. Okay? That's what we were working with. But we have to define a couple of things here. So if you read all the way down here, here's what I'm going to say to you guys. Let's read the definition of a random variable. That's a variable. It's a letter that typically holds a numerical value and is denoted by the letter X. This variable represents the different outcomes for an experiment. So we're going to have 2 things to consider. X, which is, and let's write this down, is a random variable. And in this question here, we're going to let X, that random variable, be here, equal the number of children. So remember, what I said here in the definition is it's a variable that represents the different outcomes. So we have to describe here, what are the outcomes? Right? What are the outcomes that you have when you actually have children? Well, what are the responses? Right? People can respond different ways. They're going to respond and say, I have no children, I have 1, I have 2, I have 3. So in this case, X is 0, X is 1, X is 2. Now, if you guys look at this table here, I want to ask you, let's think about this. Let's be logical. Where do we stop? If X is the number of children, look at that first column here. Where do we stop? Do we stop at 10? Do we stop at 11? For this example, where do we happen to stop? Can you guys read that and see that? So let's ask you. What's the most number of children that people have in this table? Thank you, Yvette. We stop at 5, 3, 4, and 5. Good job. Okay. So we have here as outcomes 0, 1, 2, 3, 4, and 5. Okay? Now, all we're saying is, tell me the list of outcomes. The list of outcomes are the number of children. This is what we let X be. So that's all we're talking about. This is called a random variable. It's a letter that just holds the outcomes of your experiment. In this case, the number of children, right? If we go back, we can see here the number of children. We let X be 0, 1, 2, 3, 4, 5. This is an example of what we call a discrete random variable. Now you say, what's a discrete? Well, it's just a collection of values that is not infinite, that is what we call finite, not infinite, or it's countable. We can count 1, 2, 3, 4, 5, and so on. Okay, we have another type of random variable that we'll be dealing with, which is called continuous. This variable we're going to deal with in the future, and that's a random variable that has infinitely many values and collection of values. It's thought of as the real number line anyway. So here's where we're starting here with this, and I want to point out to you guys that we have two types of tables here that we're going to look at. It's really the same table here. If we go back to the original table, right up here, I want to keep that up. Okay, if I can. And I'm going to create another table in Microsoft Excel for you guys. Okay? So let's try to do that. Let me show you that this table is really the same table as what I'm going to create for you. So let's go to Microsoft Excel. Say, okay, where are you, Microsoft Excel? Here you are. And in Microsoft Excel, of course, I'm going to do a couple of things here. Let's make this bigger. Okay, maybe even bigger. Let's do 20 here. Okay. So let's start it this way here. Okay. I'm going to create an X column for you guys. And X is the number of children in this example. We can have 0 children. We can have 1. We can have 2. We can have 3. We can have 4. And we can have 5 children. So here's my first column. This is important here. All right. So let's kind of decorate this. See if you guys can see this. Right? How big is that? Okay, that's better, right? You guys might be able to see that a little better this way. Okay. And I'm going to put here some information. I'm going to put some. We're not going to do anything yet here with that. Now, I'm going to create another column here. Okay. I'm going to create the P of X column. This also is going to be important for us. Let's make that even bigger. This is an important idea. So I'm going to ask you guys a quick question here, or I'm going to really tell you. If we go to the original, we have what's called, let's go back. We have these things here. You have, it might be better to look at the, yeah, you have, maybe if I say this to you guys, let's go to the iPad. You have here in the iPad other columns, right? You guys want to tell me what the first column is? Isn't this column here? Number of children, 0 through 5. And then the next column is the frequency column. 12, 8, 4, 5, 2, and 1. I don't want you guys to focus on that. I want you guys to focus on the relative frequency column. Because we have another definition here for you guys. This is P of X. This is how we say it in words. P of X. It's functional notation here. P of X is the probability of outcome. And I'm going to move that out of the way. Of outcome X. Okay, so this is the probability of outcome X. This is called P of X. You have a variable. X is 0, 1, 2, 3, 4, 5 in this example. And you have P of X. That's the probability of the outcome. So let me tell you something here. We have something known as a real-life probability. This is what you're dealing with. A real-life probability. This is known as my empirical rule. What that is the relative frequency is thought of as being a real-life probability. The relative frequency was the frequency over the sample size, if you guys remember that. It's a real life probability. So when we gathered data in the past and we said, okay, number of children, how many children, what was the relative frequency there, right? Relative frequency is 0.375. That's saying the chance that you have 0 children or no children is 0.375. So your relative frequency column, ladies and gentlemen, is a probability. So P of X here is going to be that relative frequency. Okay? So I'm going to create another column. That other column here is the relative frequency column. So going back to Microsoft Excel, let's read this now. Let's go to Excel and say, okay, what was the first relative frequency, ladies and gentlemen? If you look at this, wasn't it point what? 375. Okay, and that represents again 37.5%. So what this means is the probability that someone in this table, if you select somebody at random from the table that we use that's in this worksheet, the chance they have no children is 0.375. Okay, so let me fill the rest of this in. What's the chance that somebody has one child if you select somebody? That's 0.25. And let's make sure it's 0.25. What's the chance that somebody has 2 children? Well, that's going to be point what? 125. What's the chance somebody has 3 children? Well, that's going to be 0.156. And as you continue to read the table here, right, what's the chance that a person has 4 children? 0.063. What's the chance somebody has 5 children? 0.031. Okay, so look at this table here, ladies and gentlemen. What you're seeing here is what's known as a probability distribution. Okay, X here on top, remember what X represents. X is the number of children. And I can't write that down here, but that's what that is. So this column is the number of children column. That's our random variable. It's discrete. It's a countable number of outcomes. Here we have the probability of X, the probability of every outcome. So if you read the row, probability you have no children is 0.375. Probability you have 1 child is 0.25. The probability you have 2 children is 0.125. The probability you have 3 is 0.156. And the probability you have 4 children is 0.063. The probability you have 8 children is 0.031. So this is called a probability distribution. Okay, let's write that in words. Let's capitalize P. All right, you guys okay with that? So this is your first introduction to a probability distribution, and we're going to do some more work with this distribution. I want to give you guys a fact here. So if you go back here to our browser, and we're looking at this probability distribution here. Remember, back in the day, this was a relative frequency table. We used this. The sum of relative frequencies was 1. Remember we have that sum down there, which accounted for what we call 1%, right? We add this, the sum is 1. All right? Well, when I add my probability values, what do you think that sum should be? When I add these now, go to sum. That value is also 1. So what I want to remark here on the iPad, like our notes, Let's get this iPad on. Okay. Here's our first fact. Here's what you guys want to know. I'm going to write this notation. This summation means to add. Is that right? The sum over all the outcomes. When we add these probabilities, the answer is 1. Okay, reading left to right. Sum. What are we summing? Probability values. P of x. For which values of x? Every value of x. What does that sum equal, ladies and gentlemen? The value 1. That's a fact here. So I want to show you here, I did write that as a fact. If you go down at the bottom, fact, for every outcome in a random probability variable associated with the probabilities denoted by P of x, we have the sum of P of x equals 1. Okay? So it's in our notes. This is what we're going over. And this is what I illustrated in Excel, that when I add my probability values, it needs to be 1. Now, if it's not 1, if it's negative, if it's 6, if it's 2, if it's 0.3, if it's 1.8, right? That means it's not a probability distribution. So this is a trait. It must equal 1. So add the probabilities, it equals 1. And remember, every probability has to be between 0 and 1. And this is where we start here, okay? It's an important detail here. It's an important lesson. So what I want to transition here for you guys is this. It's a matter of notation. We have to become very familiar with notation. So notation, here's what I mean, and let's write this down. What we do with notation, we have to know things about words, right? Since we know that x is going to represent the number of children. It's just a variable that holds these answers, these outcomes. And of course, you say x is 1, 0, 1, 2, 3, stops at 5 in this example. Okay. This is the value that our random variable can assume, these values. So I want to write this down for you guys here. We're going to answer every one of these questions here. Right? The probability that x equals 0. The probability that x equals 1. This is just reviewing our notation. The probability that x is 2. Probability that x is 3. Probability that x is 4. Probability that x is 5. Right? So when x is 0, they're talking about having no children. This is something we have to discuss. No children when x is 0. Is that right? Because no, in some ways, is 0. So to have no children, I want you guys to read your table and tell me what's the probability of having no children. Okay? This is the probability that x is 0. What is that answer going to be? Do we have an answer? I know there's a delay here, but it's a probability of having no children. It's in your table. We can look at this, or we can look at Microsoft Excel. Okay, either one. We got Yvette. We got Joanna. Right? We got Annabelle. Good. Okay, you guys. If you read the rows, you see this? This is a distribution table. The answer is going to be 0.375. So all you guys are correct, right? James is correct, right? All you guys here, Cindy, good for you guys. Okay. All right. Thank you guys so much. See how we can do this? This is about notation. We have to first start with how to read and write, right? In terms of this probability distribution. So let's go back to the iPad. And you guys are correct. So we're gonna say this thing equals 0.375. Outstanding. That's what we're looking for as an answer. Okay. 0.375. Now, if I ask this question, what's the probability now that you have one child? Simply by reading the table, what would you guys say now? All right, do you guys have to look at this here, maybe? It's a probability you have one child. You could look at this table here, or we can go to Microsoft Excel. What does Microsoft Excel say? Look at the row. P of 1 is going to be 0.25. Okay, P of 1 here is 0.25. Read your row. So we're looking at how to read this. This is 0.25. And yes, you guys are right. And this is the answer that we're looking for. So notice there's the distribution and there's the language. So if I ask you P of 2, this represents having 2 children, right? Because X is the number of children. I'm going to say to you guys, use your table at this point and try to answer these questions. 2 children. 3 children, 4 children, and then 5 children. Give me the probabilities here for each one of these and see what you get in terms of our notation. So I'm looking for an answer to put here, to put here, to put here, to put here, and all you have to do, ladies and gentlemen, is read your tables, right? So for P of 2, can you read that? What do you guys see here? Is that 0.125? You guys are already answering. The probability of having 2 children is 0.125 or 12.5%. That's P of 2. And again, you can say to me, can I go to Microsoft Excel? Can I say, oh, here's the probability of having 2 children? Yes. What's next? This is the probability of having what? 3 children. 0.156. What's the probability of having 4 children? 0.063. What's the probability of having 5 children? Well, 0.031. Okay, so you can actually just look at the rows, and this is how we keep track of probabilities. And this is called a probability distribution. It's really a relative frequency table. All right, probability distributions are really relative frequency tables. So you guys are giving nice, good answers here. And I thank you for that. And this is how we fundamentally read a table, all right, called a probability distribution. Okay, so let's move this out of the way now. All right, double check that these are your answers, ladies and gentlemen. This is, again, about notation, all right? We got to notate what we're doing because we're transitioning to what's called probability distributions, which is also known as probability formulas. So here's how we start to do the mechanics of a distribution, okay? We're going to start with this idea. Now, of course, you guys know questions that I like to ask, questions that are typically asked, look a lot more like this. They're going to say, what's the probability of selecting, here we go. Here's our first example. And I'm going to call this 1. Okay. This is example 1. Let's put that down. Well, these are examples. We don't have to call it that, right? What's the probability of selecting, or I should say, what is the situation? What's the experiment? Having children, right? So we're having children. So what's the probability a person in this table has, question 1, at least one child? All right, at least one. So, just like you guys seen in the first test, you seen the situation where they test you on language. You know, I asked you the same exact question on the first test. The same exact kind of questions looking at a relative frequency table. And it was percent at that point, but probabilities are percents. Relative frequency is a real life probability, the empirical rule. So those kind of questions are back, at least one, and we're going to go into more detail. We're going to ask you at least 2. We're going to ask you at least 3, more than 3, more than 4, no more than 2, no more than 1, between 1 and 4, all the nice language you guys seen in the past. So what's the probability of selecting a person in this table that has, question 1, at least one child? You have to know the meaning of at least one. And at this point, I'm going to say you guys do. At least one means 1 or more. All right, 1 or more. Now, I'm going to do some notation, 1 or more. I'm going to write this down for you guys in an important way. Since X represents the number of children, if we say at least one child, that means X is greater than or equal to 1. Okay? Greater than or equal to 1. That means X can equal 1 or greater. Remember this from our mathematics courses? X is greater than or equal to 1. Thank you, Sandra. 1 or more. So, it's a probability question. Say, how do I know? There you know. That's how you know. So the probability that X is greater than or equal to 1, ladies and gentlemen, means the following. Here's the definition. It means X is 1, or X is 2, or X is 3, or X is 4, or X is 5. Now you have a kind of slight problem here, right? If you guys remember this, what do you guys see? You see what? Or, and or. What you might be thinking here of is the addition rule. And if you're thinking the addition rule, you're right. You're right. Okay? And so I'm just going to do something here to say to you, I want you guys to notice some very important idea here. Right? Your addition rule for probability. Probability of A or B, remember this, was P of A plus P of B minus P of A and B. So here's the situation for you guys, because they have to give you every detail. Here's your situation. If I just thought of it this way, let me just say to you, what's the probability so you guys know? I have 0 children. All right, let's go over here. What's the probability I have 1 child or I have 2 children? You say, Mr. Judge, is that the probability you have 1 plus the probability you have 2? Minus the probability you have 1 and 2. I'm just going to simplify the question here. This is an OR question, which means we add and we subtract. And over here, this means both. You guys remember that? Probability of both. Now, I want to remark something important is happening here. I want you guys to focus over here on this statement. Over here, you're saying you have both 1 and 2 children. Does anybody see an issue with this probability by the addition rule? Does anybody know what's going on here by the addition rule? You have 1 or you have 2 children. Can you have both? If somebody says, hey, how many children do you have? Oh, I have 1 and 2. The problem here is that's impossible. Okay? The probability you have 1 and 2 children, because the phrase is and, that's impossible, and that probability is 0. So by the addition rule here, the ands are all impossible. They're all 0. Now you say, how does that help me with the original question you just asked me? Well, here's what that means then. Right? That means we can describe this as x is 1 plus x is 2 plus the probability x is 3 plus x is 4 plus x is 5. Now let's move this out of the way. All righty? All right. Okay. All right, here we go. Now, I'm also going to do something kind of here for you guys that I like personally. You see, I see too many equal signs, and what I do is I'm going to say to you guys, this here I write really as P of 1. I write this here as P of 2. I write this here as P of 3, P of 4, P of 5. So the at least one question looks completely like this now. Probability that x is greater than or equal to 1, I write it as P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5. This is using what I refer to as the definition. Now you say definition of what? Of at least 1. Because isn't that what at least 1 means? It's 1 or 2 or 3 or 4 or 5. This is a probability question. This is the probability of at least 1. So, let's see what you guys think. And let me write it down here. Let me erase this and say to you guys, this is what I'm going to refer to as the definition. All right. All we got to do is find every value here. We need P of 1, P of 2, P of 3, P of 4, and P of 5. We need those values. And I'm going to ask you guys this question. Where do you find them? Where do you find every one of those values? Well, we can go where? Let's go to Excel. We got P of 1. We got P of 2. We got P of 3. We got P of 4. And we got P of 5. All those values are here. So what I'm going to say here is P of 1, let's remind you, is 0.25. P of 2, 0.125. P of 3, 0.156. P of 4, 0.063. And then P of 5, 0.031. So if you said to me, Mr. Judge, are you looking at these values here, these corresponding values, and are you adding them? And I'm going to say to you, the answer is absolutely, I'm adding them. I'm going to add each one of these. This is what I just found. So I know these values. For at least one, meaning one or more, I add all of those. And then you go, well, how do I add? I'm going to go to my TI calculator here. And the TI calculator is this here. What do we do? Okay, let me do this TI calculator for you guys. 0.25 plus 0.125 plus 0.156 plus 0.063 plus 0.031. And what you guys get as a final answer here is going to be 0.625. Okay? And so some of you guys, you were getting these answers, right? Catherine, Melina, Joanna. And some of you guys got these answers, way before, right? Jessica did. Cassandra did. A lot of you guys got these answers. Sandra did. You guys got these answers already from the beginning. Okay? And you guys are right. But this is the at least one question. This is an important thing. We got to know how to work with notation, ladies and gentlemen. All right, for these probability distributions. So let's look at another question here. What if I said to you, at least 2 children? Again, you have to have knowledge of the phrase at least 2. At least 2 means, again, 2 or more. Now, since X represents the number of children, okay, X here is greater than or equal to 2. That means X can be 2 or 3 or 4, or in this case, 5. This is the meaning of at least 2. So the probability that X is greater than or equal to 2 will be the probability that X is 2, or X is 3, or X is 4, or X is 5. Yes, or addition rule. P of 2 plus P of 3 plus P of 4 plus P of 5. This is the addition rule, ladies and gentlemen. So if you said to me, how do we find the probability of having at least 2 children, right, selecting somebody in this table? Well, yet again, we go back to Excel, and this time, for at least 2, we're going to add these probabilities together, right? Meaning, for P of 2, we know this is going to be 0.125, P of 3, 0.156, P of 4, 0.063, and P of 5, 0.031. Okay? So we're going to go to our TI-84. Okay. Let's add the values we said we were going to add. 0.125 plus 0.156 plus 0.063 plus 0.031. Double check to see, ladies and gentlemen, if I'm adding the right things here. Okay. What do we get? Double check. What do you guys get? Let me see. Maybe we made a mistake. Let's try it again. At least two or more. 0.125 plus 0.156 plus 0.063 plus 0.031. Okay. Is everything okay here for at least two? What'd you guys get? Anybody get an answer here? Something is not quite right. Maybe 0.37 and point. Is that right? You guys okay with that? 5. Okay. You guys get this answer? I think we're okay. Final answer. We're good. .375. All right. There we go. This is probably having at least 2 children. Now, let me go to the next phrase here. What's the probability of having no more than, say, no more than 1 child? So we need to know the chance of having no more than 1 child. We have to know, what does no more than 1 mean? Well, that's short for not more than 1. So you're not more than 1. Okay, not more than 1 means 1 or what? Less. Is that true? That's the key. How do we write 1 or less? This means x is less than or equal to 1. So we're going to need to know how to do this. X is less than or equal to 1. And so here we go. This is the key here, knowing these phrases. So the probability that x is less than or equal to 1 is the probability that x is 0 or x is 1. Okay, you guys okay with that? Thank you. You guys are good. Okay, now again, by the addition rule. What do? Probability is x is 0 plus the probability that x is 1. And you guys know I like using p of 0 plus p of 1. So if I go to my table here, right, if we go to Excel, notice what I need here. I need p of 0. P of 0 is 0.375. And I need p of 1, which is 0.25. 0.375 and 0.25. So let's add these values now, right? 0.375 plus 0.25 here. Double check. It looks like we get 0.625. So again, about 62.5%. All right, that's no more than 1, okay? Now, good, let's look at this. This is the answer to this question. It's about 62.5%. How about if I say to you guys, the next example here, this will be 3. How about if we say 4? No more than 2 children. So no more than 2. So we're going to have to know the meaning of no more than 2. Well, that's not more than 2. This means you can't not more than 2. This means 2 or less. Mathematically, x will be less than or equal to 2. Probability, x is less than or equal to 2. X is 0. Oops, let me give you every detail. Or x is 1. Or x is 2. That means p of 0 plus p of 1 plus p of 2. So I got to go to my table, right? We got to go to the distribution. Distribution, let's get used to that. 0, 1, what else? 2. So we're going to add these values here. 0.375 plus 0.25 plus 0.125. So we add these values here. Point 0.375 plus 0.25 plus 0.125 here. What do we get? Okay, you guys are right. You guys are faster than me. You get point what? 0.75. Okay. 0.75, and you guys already know, what does 0.75 actually mean? 0.75 is really, again, 75%. So we can say 75% of people in this table have no more than 2 children, which is not more than 2. All right, good examples. Good examples here for you guys. Good. Okay, let's ask you this question here. I'm going to say, how about this? have more than 3 children. More than 3. Let's see. Do you guys know the meaning of more than 3? Right? More than 3 means what? It means greater than 3. And here's something that's interesting, right? More than 3 means greater than 3, larger than 3. So is 3 larger than 3? Or I should really say, do we include 3? Right? You guys know, do we include 3? What's larger than 3? What's larger than 3 is 4 or 5. So greater than 3, ladies and gentlemen, we describe as x virtually greater than 3, this language. So remember, we do not include when it's more than, that phrase. More than, we do not include the 3. Okay? Greater than 3. So here's what we do. Probability x is greater than 3 is the probability that x is 4 or x is 5. And what that means is we just simply add p of 4 plus p of 5. So go back to what you have here in your table. We're going to add these two values here. 0.063, 0.031. Because these outcomes are more than 3. Do not include 3. Okay? Don't include the 3. So let's see what we get, right? Let's add these here. 0.063 plus 0.031. Here's what we get. 0.094. Okay, so let's look at this. 0.094. What this means is about 9.4%, right? 9.4% of couples in this table have simply more than 3 children. That's what this means. Okay, so don't include the 3. All right, number 6. How about if I say less than 2 children? So we're going to have to know the meaning of less than 2 children. Okay? This is language again. Less than 2. Well, what does that mean to have less than 2 children? Remember, less than 2 is strictly smaller than what? 2. Or you can go back to algebra, beginning algebra. Less than 2, we have x less than 2. The number of children is less than 2. We do not include 2. So the probability of having less than 2 children, don't include 2. You can have 0 children, again, by definition, or 1 child, or here, not or, has to be strictly less than what? 2. Smaller than 2. You do not include 2. So the or statement says we have p of 0 plus P of 1. And yes, both Sandra's correct and Annabelle's correct. So we're going to have to add P of 0 and P of 1. Go back to your distribution. Add these two values. P of 0 we know is 0.375, and then P of 1 is 0.25. So 0.375 plus 0.25, ladies and gentlemen, you're going to get 0.625. And yes, Catherine Molina is correct. 0.625 is the answer in terms of probability. Okay, and what that means here is 62.5% of people in this table have less than 2 children. That's an important detail. 62.5%. Good. Outstanding. Now, I'm going to say here, number 7. Between 1 and 3 children. Okay? Between 1 and 3 children. So here's something we do have to say to people. Okay? What does it mean to be between 1 and 3? Well, sometimes people say, oh, it's 2. And if you said 2, you're fine. You're correct. Yeah, it is 2. But I want you guys to know that we're going to have to be inclusive here. All right? We're going to have to include the 1 and 3. So if you have between 1 and 3 children, they really want you to be inclusive of the 1 and the 3. So mathematically, what we've seen in beginning algebra is that 1 will be less than or equal to x, which is less than or equal to 3 because, again, x measures the number of children. 1 is included, 3 is inclusive. This is how we answer the between questions. So make sure you guys are aware of that. You must be inclusive. So in this answer, here's what you guys are going to do. The probability that x is between 1 and 3, that means x is 1, or x is 2, or x is 3. Which is going to give us P of 1 plus P of 2 plus P of 3 here. So we're going to have to add these probabilities. And I'm going to go to Microsoft Excel again and find 1, 2, and 3. These values, right? 1, 2, and 3. Okay. Now remember, P of 1, when we read the table, is 0.25. P of 2, 0.125. P of 3, 0.156. When we add these, let's see what the TI gives us. 0.25 plus 0.125 plus 0.156. And ladies and gentlemen, some of you guys answered like 5 minutes ago. .531. And if you answered 0.531, looks like you're correct. Okay. And that's 53.1%. So 53.1% of people have between 1 and 3 children. Okay, good job. Now, here's what I also want to do for you guys. I want to give you a very important remark here. You guys are going to care about this. go back to the at least one question. Let's note. At least one child. And we said that meant one or more. And that means x is greater than or equal to 1. This is the first one that we remarked with, or the first example. And I want to say the complement rule can be used here as well, meaning the probability of an event is 1 minus the probability of its complement. Remember that? Non-E. Here's something that some of you guys may have already known that you can use. Go back to the last lesson. The probability of at least one child. The probability of at least one, remember, was 1 minus the probability of what am I going to say here? What am I going to put in here? This is key for today. Remember, probability of at least one of anything is 1 minus the probability. What goes there, ladies and gentlemen? Let's think about this. If I had a bag of Flaming Hots, I'd give it to you guys. Anyone? This was from yesterday. Probability of at least one of anything is 1 minus what? What is it going to be? For a bag of Thank you, Annabelle. None of those things. That was the lesson from yesterday. So, I'm going to say to you guys, this complement rule is going to save your life, ladies and gentlemen. And so we could have said in the following here. Here's what we could have done for question 1. That's 1 minus P of 0. And you say, well, what was P of 0 here? Do you guys remember P of 0? That's 0.375. So we can say this is equal to 1 minus 0.375. And if you guys know, that's 0.625 here. All right. You guys okay with that? Let's kind of see if we could get a nicer square. Which again is 62.5%. So, moral of the story. Did we get this for question 1? The answer is yes. We could use the complement rule, ladies and gentlemen. And I'm going to say here, it can be expanded. Remember the second question, at least 2 even. So let's try to do that one. Let's note for the phrase, at least 2 children. Here's what I want to leave you guys off with. This is going to be important for us in our future. Yes, this is 2 or more. Yes, we can say x is greater than or equal to 2. So here's what I want to show you guys, all right? The probability that x is greater than or equal to 2 is 1 minus what? You can use the complement rule here as well. All right, we could use the complement rule. You just have to tell me, what's the complement of at least 2? This is the phrase, at least 2 children. If you could tell me what the complement of at least 2, ladies and gentlemen, I'll put it in red. We have something. Complement of at least 2. Let's think of the definition of what at least 2 means. This is 2 or more. So x could be 2, or x could be 3, or x could be 4, or x could be 5. Is that right? So this is the meaning of at least 2. Remember, the complement is the logical opposite. So, can you tell me which outcomes are not there? Thank you, Michael. Thank you. Let's put here Flaming Hots for Michael today. Let's put it over here. All right. Michael's correct. That means 0 or 1. These outcomes are not there. Okay? And so this is P of 0 plus P of 1. That portion. But don't forget, that portion is a sum. So go back to some algebra. That's going to be a minus sign still. That's going to be a 1. So here's what this means, ladies and gentlemen, algebraically speaking. Thank you, Michael. Let's get rid of that so everybody can see. Okay. P of 0 or P of 1. Those outcomes are not there. That's the complement. So here's what you can do. This will be 1 minus P of 0 minus P of 1. That's how we can also answer the at least 2 question. And that's going to be extremely helpful for us. Outstanding, Anthony. Outstanding, Joanna. You guys are good with that. So here's what I'm going to say. Just subtract the outcomes that are not there. P of 0, P of 1. You subtract, ladies and gentlemen. Notice. So if I know what P of 0 is, I got to find what P of 0 is. Well, that was 0.375. I got to find also what was P of 1. Well, that was 0.25. So if I take now 1 minus 0.375 minus 0.25, ladies and gentlemen, I'm going to get our answer. So I can go to the TI here and say, okay, TI, 1 minus 0.375 minus 0.25. And ladies and gentlemen, I get what we got earlier today. 0.375. Okay. Let's see if we can write this nicer. I got 0.375. Let's see if I could get a nice rectangle. And as we knew, this is 37.5%. 37.5% of you guys in this table who responded have at least 2 children. So this is how we handle the at least 2 situation using the complement rule. Outstanding. Okay. I'm adding to your homework here. This is 5.1. I'm going to add some things to your homework. I'm going to add for now, you're going to do, let's say this, 7 to, well, let's do something like this for today. 7 to 13 odd. So for sometimes people say, hey, what's our homework? I'm adding 5.1. 7 to 13 odd. I'm going to include this in the announcement for your homework because people are saying, hey, what's my homework? What's going to be on the test? Everything that we had before until now. it's corresponding to the announcement that I have, okay? So this is from your book, 5.1, 7 to 13 odd. It is also, if we go to my website, we're going to start this. Go to the browser. And I go, okay, browser, what do I do now? All right, we're here, over here. If we go to the website, if you guys remember, this here is also the start of statistics lecture. I'm going to tell you guys specifically 9. So on the web, we have statistics lecture 9 here. Okay. Right there, because what do you guys see over here on the right? Probability distributions. You guys see that there? So this will be statistics lecture 9 as well from the web. SL statistics lecture 9. What's the title? Probability distributions. Okay. So, ladies and gentlemen, we're out of time. If you have any additional questions, come see me during office hours. Again, it's in Canvas. So get used to that Canvas interaction. Download it from your phone if you have to, or go to it online. And I'll be there at 10:30. So we got to go. I wish you guys well. Stay safe and have a great day, okay? Thank you. Thank you guys so much. You guys have been amazing.